So, good morning, everybody. It's a sunny Friday here off the Australian coast, and we are once again on board our research vessel Falco, the Schmidt Ocean Institute, for ROV SuBastian dive 329. So, for the time being, the two astronauts of the Blue Planet sitting next to me are Jason Rodriguez and Cody Perez. So good morning, Natalie. Good to see you online again. And good morning, Diane Ingram. Very soon Chris will be also sitting here. And good morning to the many friends that are now following the expedition, more or less some from the very beginning, other kind of later. So I can see the unknown explorer and Jason in Michigan, and Mark and others. Okay, here is the control room, and we are already working on the bottom of the Perth Canyon. Actually, this is the 15th dive of the current mission, the Canyon Coral Australia Adventure. Let's start a month ago in Albany, and then we spent many weeks to actually explore the Bremer Canyon, and then a couple of dives in the Lewin Canyon of the southwestern coast of Australia. And then also because of the bad weather, we moved to the very last target of this expedition. It was Perth Canyon, that we already started some 5 years ago. So now we are actually a little bit integrating the knowledge we got 5 years ago with new info. So by this time we are almost 2,000 meters below the surface. Temperature on the bottom is 1.7 degrees, and we are getting the second push core from the muddy plain here. This operation is directed by Alexei. Alexei is the one that is studying the foraminifera into the sediment, or anyhow in the area, but also by coping their distribution with important environmental aspects. That's why he's also looking at the pore water in the core. Once again, push core is a very simple operation in a way, but depending upon the texture of the sediment, it could be a little bit demanding, and as in this case, they discarded this core, maybe too short, something like that, and they will try to get another one. So at this time, in the control room, beside Cody and Jason is the chief ROV pilot in this moment, and Cody is involved in operating the robotic arm. We have Karel Rice, a gentleman from Estonia that is quite attracted from anything that is marine technology for the Schmidt Ocean Institute. I think that he was involved during the night and during the early morning also in a very deep CTD that has been actually operated before taking the ROV to the current spot, and they got hydrological cast down to about 3,800 meter water depth. That is the deepest we have so far from Perth Canyon. We didn't achieve such a depth 5 years ago when we were in a mission led by Malcolm McCulloch from the University of Western Australia in Perth, that is also an important member of the current expedition here, that is led by another geochemist from the UWA in Perth, is Julie Trotter. Co-PI with the expedition is Paolo Montagna from CNR in Italy, but he left the expedition at the end of the first leg in Albany. Also in the control room we have the people involved in filing the information regarding the bottom type, substrate, samples that we record, images that we are taking, and of course the biological assessment of the environment. And this is the responsibility of Anara. She's from the Western Australian Museum in Perth. Minutes before, we had also Paula Cartwright performing the same duty. And next there is Alessandro Remia Dando. This is his nickname. He's also from the Institute of Marine Science, CNR in Bologna. Like Federica Foglini, who was getting that position in the previous leg, the Bremer Canyon leg, and myself, Marco Taviani from the same institute, kind of paleobiologist and sort of expert of the sea ecosystems, especially with corals and seepage, this kind of stuff, and also trusted to be responsible for the narrative of the real-time streaming. Last but not least, we have our expert in fish is Todd Bond. Is also in Perth. Is running a project on fish ecology, and this is, I think, the very first experience on real deep sea fish ecology. Nothing better than be on the sea bottom and watch the fish while in their habitat. So getting notes, recognize them is not always so easy, but we have plenty of course, of footage and stills to refine our taxonomic assessment later, and above all also to look at what the fish are doing, which is actually the total environment surrounding that. And also I see that Robin is online once again, like NGC 6210. Oh, what a complicated code to memorize. Reports are a calcified organism or not, plural, resting in here some such full being one water, or maybe for the totality through time. Natural artists at work. You can see this geometric marking by the resident benthic invertebrates. We observed that some of the worms and some of the sea cucumbers are very good in producing interesting marks on the seabed during their metabolic and catabolic activities. And so coming back to the concept of paleoclimate, by finding the signal in the modern, then we have a powerful tool to have approximation of what was happening in the past by simply of course is an understatement, another sea cucumber, by simply actually looking the same signal in fossil coral. So then we can understand happening using water, glass bottle, bringing down to follow us. Number of the very young will be not more the case. Only pathologists, physics, they had their drifter in your own. There is by having the various any of the sandy elements of by a lot of basic information. Is the atmosphere, land, the current, so the that can be, say, restricted. Okay, we got one of this multi-armed asteroid for later analysis into the museum. Again, there is a good possibility that some of the life we have intercept visually most of the time during our exploration of the deep canyons here could prove to be new to science, and in such a case it's always a good idea to have real material for understanding the anatomy and the genetics. So here we have sea cucumbers. So it took times to we got we had previous today and Madagascar and India and Antarctica. Case of currents in the next to the shore in a few meter water depth. Dunes also, they do the same on land, but also nice organism. And also we have a similar response in the deep ocean in case we have currents impinging on the sea bottom, and sometimes the currents are so strong that they even provoke dunes, hydraulic dunes that move around, as like in the desert. Another tripod fish. Use also the occasional sponge. Obviously, for a biologist, it would be really great to always to collect a bushy specimen and to have a perfect binomial Latin name to put on, and then to make a list of the fauna characterizing the Perth Canyon or the Lewin Canyon or the Bremer Canyon. Unfortunately, we have really always to compromise a little bit by the need to fulfill our needs for the project. When you make an application to the Schmidt Ocean Institute, you have a proposal, scientific proposal that, if approved, it will be the very reason for the exploration. Obviously, any other contribution is highly welcome, but cannot be priority with respect to the core of the project. This for Falcor, but also for any kind of other scientific exploration. So we put a request to Jason for collecting a rock here to see if the substrate is different from what we have seen. Obviously, some of these blocks have been slumped from the cliff, but we have indication through our multi-beam map that also there is a potentially interesting situation on the bottom here. And rocks may be the silent witness of a distant geodynamic event of enormous proportions. So the rifting on this part of the continent from the other land masses. So then, once the best position for the ROV is selected, then
These ones or those ones? Which ones do you like more?
Cody will probably get, or will try with the robotic arm to pick up one of these rocks. Sometimes they are fixed to the substrate. It happened especially on the cliff, so there was no possibility. We thought was just a pebble detached, but in fact either you are taking on board the entire cliff, or but then we have always a plan B, plan C. And let's say that failure is not in the dictionary of the ROV pilot, so it's always a matter to wait the right time and the good occasion. And of course, it's great. It's great news for scientists on board whose major effort is only to say, "Oh, I would like to get this one. Oh, could you pick this?" So from desire to actual sample, there is a technical gap. For our part is very easy, theirs is very complicated and technologically advanced. That's interesting. That's okay. As usual, you got the impression that some of the rocks in the Australian canyons are hard, but it's only because the patina, that is a later addition to the rock, by being the rocks actually flashed by We have done our small collection rocks. We observed maybe three types: the sandstone and a whitish. We will see the nature on board, possibly limey rock, and the brownish one that collapsed in crumble. That was, like an SA mudstone. So this boulder here is acting like a perfect settlement base for a variety of cnidarians. We will have a quick exploration. It's beautiful anemone. We should remember that at this depth the water column is undersaturated. With respect to aragonite, that is the mineral that is making up the skeleton of the stony coral, those in the order Scleratini at least. But yesterday we were pleasantly surprised by finding one, a living one, coping with these undersaturated waters. So this is a sample for the Western Australia Museum in Perth, which asked a number of specialists for the different taxonomic groups. We had before on board for the first leg Andrew Hosey, is a curator for crustaceans and worms. And by now we have Anna Ara. She also has a taste for crustacean. Yeah, it's always interesting to see these transparent sea cucumbers ingesting so much sediment, and then of course they leave behind these strings made up mostly by the sediment, from which the various food particles have been extracted and absorbed. Being transparent, you can see inside the animal. Such a beautiful cnidarian is obviously ready to predate whatever is passing next to its tentacles, and also was using a stem, reinforced stem, for its projection over the muddy bottom. This always enhancing as optimize its capability to intercept food particle. Can we have a look there? Yeah, Anna is now classifying the previous cnidarian and Venus trap anemone. Vaguely resembling one of those carnivore plants that you see in the jungle. So the main architect of this miniaturized Nazca-like figures, again one Venus trap anemone, is a cornworm that we observed, sample one yesterday, Torquarator. Is obviously responsible for a substantial reworking of the sediment bottom here by judging by the number of geometric marks, characteristic geometric marks left behind, with no worm on site. So it means that, yeah, first of all, probably the environment here is not too reworked by currents, and so these traces can be relatively old, and so they stay for a while. As I was mentioning yesterday, is plenty actually of fossilized example of this prints, these marks, in the geological record. It's full of situation where you have former bathyal, deep water, and not only sediments, where you have this geometric shape still petrified forever, reminiscent of what was the activity of feeding activity or resting activity or dwelling activity of bathyal life or life living in the deep sea during the past. And before the start of deep sea ocean exploration, and especially deep water camera recording, they were really puzzling the scientists, because you could only speculate about who were the makers. And by now we know enough to categorize the main categories, the main types, according to the organism responsible for producing them. Again, another aerial view of a acorn worm. The first marine litter of the day. Yes, you observe various actually artifacts due to human activity and perhaps misbehavior, plastic bags and other relics of our activity on the surface, of course. Although yesterday we also got some used ammunition, anti-SAM war game remains. Not much, but quite visible in the bottom of the canyon, also because the situation here is a sort of sluggish, and burial will probably take some time. We are by now at exactly 3,000 meter water depth. The temperature is still 1.7 degrees. Small decapod. Well, of course, you want to defend its privacy. Well, regarding the gelatin-looking critter, I don't know exactly which one you are thinking of. One that was quite interesting. That was possibly the predator tunicate. We didn't, and then, in fact, Anna is reporting that we were collecting a sponge. Yeah, in our basket was nothing more. Another artifact. So we have squat lobsters, and now we have this hermit crab. These two anemones. Was a barnacle before, and let's see if it's so important to endocrinoid. And by this time, Jason has been replaced by Chris Ingram as chief pilot, while Cody is still sitting for a few seconds, I believe, because normally the shift is including both ROV pilots. And next could be Adam Wetmore, a Canadian. That means that by this time we have two people from Michigan contemporaneously following the dive, one ashore, one here on board our Blue Planet spacecraft. So again, another acorn worm, torquerator, interesting animal, responsible for so much sedimentary working here, on a battle plane in this, on the left side of the Perth Canyon. We are surveying an area that we haven't seen during our 215 exploration here, so totally new to us. But yes, we were surprised by the discovery, absolutely unpredicted, of a relatively large solitary coral, solitary stony coral in 2,200 meter water depth, living in undersaturated water. Yes, I see that people on the live chat is making a consideration that also we made many times, but still, as obvious as it sounds, sometimes we forget about it. This is the very first and in no likeness last time that any of these animals that we are seeing here are illuminated, so they will see light. So sometimes this is a little bit interfering, let's say, with the business as usual in the ecosystem, depending where you are. For example, there is a canyon in the southern Adriatic coast of Italy, where we have cold water coral grounds like here, like in Bremer. And there, once we were down with a big, almost working class German ROV, was in 2006, I think. And okay, we put the ROV lights on this fantastic coral reef of the Abyss, and there was big activity, a lot of cozy activity there. Swarms of copepod, they started to move around, attracted by the light, I think, and in large numbers, probably not the same number that they used to be in total darkness. And of course, was a big party for the microcarnivore cnidarians there. They were catching a lot. I think it was just the only time in their lives they have so much food. So we are at once. So now we are taking a picture of this sponge in the habitat, and we are going to sample the specimen for further study and biological assessment. So for Linda, just joining the group, what is causing the circle in the sand, this kind of, as we nicknamed them, miniature Nazca figures, they are produced by the feeding activity of an acorn worm, Torquator, that is quite common here. We are keeping seeing many of them while producing the circle, but many more circle witnessing their form activity are actually marking the bottom here. This nice geometric figures, strings. Okay, Linda, now you can see who is responsible for making the circles in the sand. That's the acorn worm. Thank you, Kay. Thank you, Jason. Very kind of you both. Oh, yes. Good afternoon, Australian time, Miss Simpkins. By this time, Taylor is not in the control room, but she can be here sometimes, I think. So if you want to keep tuned. And welcome to Radigar also, the companion of all this expedition, ashore. Now we are, Chris is driving the ROV SuBastian westwards because our multi-beam map is showing that we have actually some topography and the cliff that we wanted to climb sometimes this afternoon. By now we are still in the Battial Plain on the bottom, left side of the bottom, the Perth Canyon. Later on we will put the multi-beam map to give you an appreciation of the general topography. See Cucumber Land. Truly, this 1 month plus of exploration of the muddy plains in the Bremer Canyon first, and then in Lewin Canyon, and now in the Perth Canyon is showing how relevant and diverse is the sea cucumber, okay, let's say holoturian diversity here. They are a consistent presence on this kind of environment. That is not surprising at all. Consider the way to feed themselves, that is largely by scooping and ingesting the sediment and leaving behind the undigested mineral part of it. Actually, I like the echinoderms for their strict relationships with a specific family of very tiny gastropod, sea snails. I call it the Eulimidae. Most of the members in the family they are very difficult to set apart based on the shell characteristic only. It's just an ivory acuminated shell, smooth, but they can only live by parasitizing echinoderms. Now that's the story. Some are staying just outside some part of the host. It could be a sea urchin, so among the spines, next to the mouth, the ambulacral area. They can often be spotted kind of easily because the shell is white and the sea urchin may be normally black, purple, brownish. They are very highly protected by the spines, so they offer no ground to predators. And the same is true for crinoids, for sea lilies, for brittle star, so ophiuroids, for sea stars, so asteroids, where most members in the family, we are talking about thousands of different species, often species specific. So one type of sea star has one type of such parasitic snail. Up to holoturians, but holoturians mostly they do not offer too much good place for them to attack and be safe. So they resorted to leave some of them inside holoturians, actually in the digestive trait. So where they stay in total darkness and once forever. And so they, being inside the fleshy part of the animal, in this dark tunnel, they don't even need anymore a shell. So they are shellless. And so you have normally a pair, a male and female, spending their entire lives there. So what is evolutionary and ecologically remarkable. I'm not sure that this is the best and first choice for any ecological niche, but is adaptation. Other, in fact, are not living outside the echinoderms, but inside. So they will develop their entire life inside, let's say, the arm of the sea star, so that they make an improvement to my mic. So perhaps my voice was coming strange. Maybe with an Italian accent, that's no longer to be the case now, with the new mic. And and those they are living inside the arm of the sea star and causing a gall. So you may understand from seeing the sea stars if they have a parasite inside the arm or not. This is not only for deep water elements, member of echinodermata, but also for the very shallow water one. So if you like natural history and next time you are on a pier or a shore and you get to see one sea urchin or a sea star, maybe you may spend some time to look carefully with a magnifying lens for this kind of very specialized animal. Finally, we are finding our bedrock here. We have small ridges here and then steeper ones. By this time, also Russell Caulfield, the Scottish ROV supervisor is coming in the control room. So we have 5 on board, whose names now should be kind of familiar to at least for those who are following the expedition since the beginning. Chris and Adam, the northern Americans, one being from Michigan, the other being from Canada. Cody and Jason, they are from the southern part of the United States, though they represent Texas and Louisiana, plus Arkansas. And Russell is from Scotland, resident in Eastern Europe and also partly in Canada. Also Nick, that is one of those guys who originally contributed to design and actually to prepare the ROV SuBastian or Schmidt Ocean Institute. Is traveling with us, totalizing 6 people. It could seems too much for an expedition of only 35, but it is not. Absolutely is not, because this is an ROV expedition. It's just ROV expedition and plus some other, let's say, collateral action, important but collateral. One, of course, being the CTD or the hydrological casting, that is fundamental. And also the occasional towing of the surface water for microplastic and other things using a manta net. And SuBastian, in a way or another, means almost 24 hours of work. Is not only the long time, the 12 hours, let's say, needed to prepare, launch the ROV, explore the bottom, drive it, taking sample, etc., and then retrieving the ROV on board, on deck. Okay, that is part of the job, and then always there is the maintenance and the check. These are delicate machines in constant need of being controlled, fitted, prepared, maintained, and otherwise we cannot have the privilege to explore the sea bottom as we are doing now. As all machines are always susceptible to any kind of problems. Hardware, software, electronic, electric, hydraulic. And the ROV is really, the SuBastian is very huge and complicated. So if you like so, just visit the Schmidt Ocean Institute website and go through the specification of this machine. There is also a nice animation, and you may have a better perception. we may we want to collect another geological sample for calibration of the environment. In the meantime, we are exploring the block to see if we saw some cnidarian. We are always looking for those with a skeletonized cup. So by now we have our small piece of substrate. Although it possibly is a fallen block, but we didn't see too much relief around here, so perhaps it's a good representative of the local bedrock geology. One may wonder why we touch the tentacles, because some of the cap corals are not so obvious. I mean, we knew that was in all likeness a soft water one, but yesterday we were a little bit tricked by one of this anemone-like looking cnidarian that in fact proved to be a cap coral, not a very common one, obviously. So now we resume our exploration of the bottom here. Perhaps later Karel will put an inset showing the topography for your appreciation. We may have an overview of the Perth Canyon, this huge structure offshore the town of Perth. That is Robin's home place, as far as I understand. And perhaps then to see much closer the specific area here. Nice shrimp. Perfectly happy at 1.7 Celsius.
Is that a polychaete one? Is that a free swimming polychaete?
Hermit crab. Yeah, there is some life here. Also visible one. So this worm was attracting the attention, thought, and also Anna decided that it is okay just to have a film and a photo. And so we resume our exploration at the bottom here. And by this time, Nick, the sixth ROV component of the team, is in the control room. So thank you, Karel. So for your advantage, now is putting the inset where you can see exactly the location of the canyons that you've seen in these days. The big island is Australia, for those that are not familiar with this continent. And the colorful spots are actually the multi-beam maps that we produce. The one to the right is the Bremer Canyon, where we stayed 3 weeks. Lewin is almost invisible because we only had a couple of days there. So just the time to actually to collect some important coral fossil and living corals there. And then we move off Perth, off Fremantle, and this is the huge geological feature known as Perth Canyon. So it's very long. You see it's meandering about more than 120 kilometers. East to west is widening into the bathyal plain of the Indian Ocean. And by now we are visiting, and Carol very kindly showing where we are diving now. Right. So we start from the bathyal plain in 3,000-meter water depth, just roughly to the foot of this sequence of cliff. Obviously, the colors are not the real one. These are false color. You can use the colors you want because you impose the code, and then your algorithm will produce the map accordingly. By an unsigned agreement, you prefer to put the deepest part, the deep blue, and the shallower part with more bright color, grading from green to yellow, orange, red. But it's absolutely up to you. Say that after a while, when you've seen that most of the maps produced by people around the world are using the same color code, then you read the topography in that way, and if they inverted the colors, you will think that you are always going the other way around, and so you are a kind of lost. Now the 3D in the inset is no longer actually the large-scale map, but it's showing just the detail of the situation we are experiencing right now. More abrupt, steep topographies. If some of you by chance was following yesterday dive, you observe many times the maneuvering was complicated. So another small ridge of bedrock, probably just okay meeting us. Actually, this kind of substrate is offering a good acoustic response to signals in what we call the backscatter. So in the end, we are capable to understand if the bottom is muddy or actually hard by evaluating the reflectivity of the bottom itself. Another Holoturian engaged in crawling onto the bottom for mostly for food. So now we are in about 2,860-meter water depth. We crossed through various ridges. We are still heading west, where we should meet sooner or later. Further other cliff, with the hope before the end of the dive today to climb a little bit and see some of the Canadian life attached to our substrate. So far we are just meeting a lot of different animal life, so shrimps and hermit crabs, the usual geometric marks left by the acorn worms, and sponges, tiny sponges like the one on the left, and the almost ubiquitous Sycocamber holoturian. A big shrimp. And so by this time Taylor was joining into the control room, replacing Todd, at least for a while. Nice sponges below. A lot of bioturbation due to these crawling creatures like this haloturian, but also the pervasive acorn worm, leaving these interesting spiral marks behind. Taylor? Surprise!
Hello from Perth Canyon.
Hi, Taylor's mom. Hello.
Kay, she was your daughter.
Also, hey, Dad. Perth Canyon's been great.
Don't expect any return from here. We may try to have a quick vision of the control room now, so you could see the people working hardly to conduct the ROV SuBastian operation on the bottom of the Perth Canyon. So Carol will be the gentleman in the background, and then Adam and Chris, the ROV pilots, Malcolm McCulloch, my left side. Right. Okay. And Taylor, come again. So here we have the graduate student Taylor. Maybe if you come here, it's easier. All right. The camera's there.
Looks like it can. Okay.
All right.
Go.
Where are the corals?
The next 2,000 meters we rise.
Maybe we can ask her for some corals.
Sure.
She'll drop them down for
Definitely.
us.
Okay. So we go back to operation. Thank you, Karen. Our pleasure, Kay, but maybe it's because of my accent, but it's Karel, He is a gentleman from Estonia. Yeah, this beautiful star-shaped feature actually is a classic in a science called ichnology. That means the study of trace fossils. So for long we have seen this in the fossil record, for example, Cretaceous Eocene sedimentary rocks representing ancient deep sea floor, and scientists were wondering about the makers. And then finally, with the advent of deep sea photography, 1 second, this is again for the people that is watching now. That is the acorn worm, Torquator, something like that. Torquator, okay, that is responsible for ingesting the sediment and then letting the sediment passing through the body, almost untouched, only the food particle absorb, and then it is released in this geometrical fancy shape. But this is something that is actually like to make a sculpture of the seascape. On the other hand, the other star-shaped features is different. Is a negative relief in a sense, not a positive relief. Again, responsible are worms, and they dwell into the soft sediment, and then they probe with their long apparatus any direction into the surrounding sediment, being very careful never to cross again the same layer, in such a way optimizing its feeding possibilities. At the end you will get this beautiful and regular starry marking of the bottom, and once its feeding is complete, the worm will move to another spot, and they will start again this geometric regular feeding procedure. Again, this has been spotted because a time-lapse deep sea camera left on the sea bottom, on a muddy sea bottom, featureless more or less as the present one, captured the image of the maker. So obviously this biological information and ethological information have been later conveyed into textbook, and now if you look at the chapter ichnology, deep sea traces and so on, you will find explanation like the one I offered you. Regularity of these traces were really puzzling past geologists and paleontologists and sedimentologists, having no clue about the makers. Some are so geometric to leave the door open to any bizarre interpretation. For instance, there is a Paleodictyum problematicum, is one such strange ichnofasces, so actually trace fossil. And some are honeycomb shaped, so think to imagine a 19th century geologist walking the Apennines or other chain and seeing, or the Alps, and seeing these marks in the rock. So what could be responsible for that? Now we know the action of bottom deep sea invertebrate life. Well, weird question indeed, interesting, bizarre. I don't think that the Coriolis is controlling the direction of, let's say, catabolic events on the seafloor, but it could be a new field of exploration for new frontiers scientists. Yeah, and talking about continents, I can see that still, at least the people active on the chat lines are mostly from USA and obviously Australia, wondering whether any European is indulging in watching what is going on in the Perth Canyon. By now, the time schedule is decent also for Europeans. It should be any hour between 8 and 9 o'clock a.m., depending where you are. So we were just talking with the pilot about the cliff that is ahead. Yeah, but I think that we spot the Canadian, but this is a soft one. And
Continuing on.
and then some rocks. Yeah. Another headless chicken monster intimidating us with little success, but very graceful holoturians.
Okay. I can take advantage of this moment to let the ship get ahead of us a bit.
What would Jimbo choose? Okay, so Jimbo, you're trapped in a very remote location, and there's two planes.
So we have the occasional sponge, stalk sponges emerging from the muddy substrate. There's still about 1/2 kilometer to travel westwards to intercept again a considerable wall. We hope by the end of the day to climb the wall. Say that we miss any kind of information from this part of the Perth Canyon. That was an area we consider the east side to be a little bit under more sluggish situation than the west side for some reason. And so for our search of the sporadic cold water coral life, we decide to concentrate mostly on the west side. Actually, that would be more or less the opposite depending where you look at. So it will be the west side is the most sluggish, and the east side is deeper. And in fact, during our 215 expedition, we observe and we collect here and there some live coral life in the form of the stony corals we are using for that and the current project. So cap corals, stony corals like Desmophyllum and allied species, and the frame builders, colonial stony corals like Solenosmilia. We found a few, including some last glacial age graveyards or dead colonies. By this time, the first two stations dives we did yesterday and the day before were repetition of the 215 dives to collect more material, more dead coral material. Although yesterday we have been pleasantly surprised by the finding of one living cap coral, stony coral in 2,200 meter water depth, in undersaturated water as we call them. That basically would be waters where it's very difficult to precipitate calcium carbonate, therefore the skeleton on the opposite is very easy to be dissolved. So obviously the animal was finding a sort of compromise between laws of physics, preventing an easy precipitation of calcium carbonate in such a situation, and its own ecological niche. So the animal was putting some extra energy to counteract the environmental difficulties. This is not surprising if I think about a very prohibitive environment where to produce shells. That will be Antarctica. Very aggressive, and cold water are far from being ideal for the precipitation of any sort of skeleton there. Yet we have various animals that are braving the environmental difficulties by secreting a shell. Entire groups are banned from living there because of the low temperature and environmental stress. But some obvious groups like, for example, sea snail and bivalves, barnacles, and including stony corals, a few representatives live there. Normally, it happens that they have a very small shell, so they don't expose too much of the shell carbonate to dissolution by the surrounding seawater. Only a few mollusks have a relatively large shell, and also some barnacles. Otherwise, it's a word of miniaturized animals. On the opposite, other inhabitants of Antarctica, they have a giant body. This applies, for instance, to sponges. There are meter to meter big sponges, or to the sea spiders, which include in Antarctica the giants of the family, very large, even 30 centimeters in diameter. Crabs, real crabs, no longer live in Antarctica, but they were living around Antarctica when the climate there was milder, so we have fossil evidence of crabs living there 30, 40 million years before our age. But by the time Antarctica was not the giant fridge that we know today. Yeah, there is an observation about life to be different in the east or west coast. Obviously, it depends. Here we are talking about east and west side of the same structure. Yet there is a distinct zonation, as technically ecologists call the distribution of animal plant life. Being here the action of currents less intense, you see that there is a lot of mud drape, and this is of course is actually dictating the quality of the life on the bottom here, but also in the water column. So we have an abundance of mud dwellers. The few rocks we have seen are intensely colonized by some cnidarians and sponges and the occasional barnacle. They get advantage of something projecting out of the muddy bottom for also the stone itself is a little bit accelerating the flow of currents around, so for feeding reason they may use this ecospace, and even if the overall the circulation here is a kind of wouldn't say dead, but sluggish for sure. They don't really need to share the resource with too many other competitors. Just in front, we on the same canyon, but just on the east side, is plenty of steep cliff, and so there we have a concentration of filter feeders. So east and west side, obviously, being topographically and sedimentologically and hydrologically different, support sort of different communities. There is always some overlap. Maybe the biomass is different. Here there is enormous biomass into the sediment. Also, I expect that if you take a core here and we look at the nematodes and other meiofaunal element, so those that are intermediated between the microorganism, micro form of life, and the macro and benthic and macrobenthic and megabenthic form of life that are those that we normally observe during our ROV exploration. Okay, the meiofauna would be probably very, very rich. So a big biomass is probably hidden into the sediment. You need a microscope to see these animals, anyhow. And if you talk about east and west sides, for example, of ocean, okay, situation obviously is very different. And this applies to all continents, or ocean if you want. So if you take the Atlantic Ocean, the latitude of Africa, and the latitude of Brazil, you find remarkable differences. Basically, the African western coast is deprived of coral reefs, whilst the Eastern Atlantic, in the proper latitude, of course, is plenty of coral reefs situation, with small things in the Gulf of Mexico up to real coral reefs in the Caribbean, down to the part of the Brazilian coastline. And if we talk about the Pacific Ocean again, real coral reefs are developed on the West Pacific, while the East Pacific is mostly deprived of real tropical reefs and other allied ecosystem. So while waiting the ship, the Falcor, to join our position, we are connected, we are tethered to the Falcor. We decided to wait in a spot where there is this interesting combination of benthic life, including the squat lobster. Now let's see what we have here.
Or hypercup. What distinguishes?
Oh, that's too easy.
Okay, no, let me get it. No, it's been
Alright, I'm gonna fly away now. Carrying.
because we were trying to get as soon as possible to the cliff to climb.
Okay. Oh.
On the west side of the Perth Canyon, it's a collection of beautiful glass sponges, barnacles, and we're looking for the occurrence of anything that is calcified in terms of corals. By analogy with what we have sampled and seen so far in the Perth Canyon, the nature of the bedrock here should be sedimentary and possibly any age between the Paleogene up to the Miocene. So marine rocks. Here, as we have seen many times so far, Bremer Canyon, also in the Louis Canyon, we have very diverse communities of filter feeders, all associated in the same topographic site, filtering the water column for the occasional particle of food, and always remembering that they are not really making necessarily the same function in terms of which kind of food they intercept. It is really also a function of any single animal, as they are structured. Some are very, very tiny apparatuses, down to the holes of the apertures of the sponges that can be suitable just for bacteria of that size of stuff, to the large polyps, of cnidarian that we want to explore there, that may even catch a small fish or even swimming copepods and so on. Obviously, we are now basically also distracted by the fact that we are studying the site here in search of potentially useful corals. A good question about the discovering new species. Well, it's possible, but how can we know that in advance? It's very difficult because actually we need to make comparison with other material, other species, and often we have what we call cryptid species, like for instance we collect some file clams, the Acesta. They look kind of similar one to each other, and so some species have been discovered mostly based on the genetic signature. So it's possible that some of the black corals are likely many mollusks will, and possibly also some of the polychaetes and crustaceans that we found associated with the whale fall. So the skeleton, the bones that we collect in Bremer Canyon, the chemosymbiotic community, possibly some new species will be there. Maybe a few months and years of taxonomic work will solve this problem, but only by images or even by taking one sample on board is not sufficient to make a positive statement if we found a new species.
Right there, good?
I believe so, but you know, science is a little bit more rigorous than belief, so we will see. Will be enough in the future just to eventually digit Perth, Canyon, new species, and maybe the web will disclose if something has been done. Actually, a new species has been described from the Perth Canyon based on the material we collect during the 215 expedition. And we just described a new species of sponges from coral grounds in the Mediterranean. This material also was collected some 5 years ago. So this is roughly 2, 3, 5 years is the right time to get the results of the taxonomic studies of the fauna. Interesting question about the naming rights. Well, okay, let's see what is the normal procedure to describe a new organism. Then, okay, you have possibly a specialist with a deep knowledge of the group is pretending to describe a new species from. Then you decide the specific name, but not the normally, unless it's new, the genus. So the taxonomic category that is the higher rank with respect to the species. For example, it's difficult that you find a new species of elephant and also in a new genus. So you will find already the genus, and you say, okay, in my opinion, this population from from Zambia is a new species based on this argument, and then you may decide to provide a name. Normally, it will be in Latin or Latinized. It will be geographically, so it could be Zambiensis or Zambie, so it's a genitive, or you may decide to dedicate the species to another prominent scientist working on this group or anything similar. And so it could be, I don't know, Darwini, if you want to dedicate after Charles Darwin, or to the point that you can dedicate also to your cat, if you like so. That is not a common case, but still there are fancy names in the scientific literature. What is street is that it has to be a Latin name or a Latinization of any given name you wanted to provide. Obviously, Darwin is not Latin, and so it will become a Darwini. So the correct spelling for Darwin plus an I as the genitive in Latin. And so it will be Elephas darwini. You can also think to dedicate a species upon the expedition, upon API, upon a colleague, upon the ROV, upon the ship, for example. One of the species from the Perth Canyon expedition, it turned to be Falcori at the end, so dedicated to the Falcor research vessel. I and colleagues, we dedicate some of our species to the research vessels that we were using for our investigation in the Mediterranean Red Sea. Yeah, if yours is Cello, mine is Rasputin. It's completely gray with yellow eyes. We're talking about cats. Charles Darwin has a lot of stuff dedicated after him, no doubt. Well, for those people who perhaps connect now or just minutes ago, it's a 4:15 p.m. Australian time, and here we are on board a research vessel Falcor, Schmidt Ocean Institute, and we are by now exploring by using the ROV SuBastian the west side of the Perth Canyon, an area that we haven't visited during our previous expedition in 2015, nor in the two dives we have already performed yesterday and the day before yesterday. We are into 2,600 meter water depth with a bottom temperature of 1.9 degrees. No big change since we started this morning. We started with 1.7. We were at 3,000 meter water depth here. And pilots by this time are Cody as the chief pilot, and next operating the sampling device gears when we need it as Jason. Navigation is in the hands of Karel and Dando, filing of the data is in the good hands of Anna and Ando, with the assistance of Taylor, Alexei, and occasionally myself.
You want to keep heading towards the west now? Yeah, that's going to wrap me around it.
Yeah, keep on going.
Yeah, it's very weird. Cucumber holoturium attracting immediately the attention of a biologist on board. So she is Anna from the Western Australian Museum. we saw a very diverse Holoturian population during our exploration of the Australian canyons.
Still on.
So we have an Italian connected with us, possibly an old acquaintance because he's greeting super cordial Jason. His name is Paolo Montagna. He was from Bologna, so he was on board Falcor until 8 days ago, and then he quit the expedition for the second leg in Albany, and now he's following us from back home in Italy. Hello, Paolo. Any connection with the campus today? And also we have a visit from Belgium. Hello, Siegfried. Good to see you again on following the expedition. It is interesting to see that actually the environment here is very rocky, but because of the modest strength of the current, in fact we only have occasional exposure of this knolls, of this limited bedrock popping from the sediment. Is a sedimentary rock. Hard to say. Okay, maybe is limey.
It's over here. It was a cap coral, maybe soft. Lost it now.
These are soft. They're soft. Yeah.
There was a bit different.
We will spend some time in exploring the block, always for the search of stony corals. Let's see. Maybe a very tiny one. It will be the discovery of the day, if proved. Okay. Yeah, it's soft. Okay. But again, we should not forget that here we are actually flashed by undersaturated waters, that animal that pretend to secrete calcium carbonate skeleton have problem with, and especially if the calcium carbonate phase is aragonite, that is technically called metastable. It means not so stable, in the sense that it's very easy to be transformed or to be dissolved by aggressive waters. Yet yesterday we were very lucky, and we found one such coral in in 2000 plus water depth in undersaturated conditions. So we have a hermit crab. And well, this time it will be a pleasure also for me personally to greet another Italian connecting with us. Therefore, I will say ciao Barbara, un piacere vederti finalmente connessa con la Falcor e con me e con noi. Se hai pazienza, fra qualche minuto magari ci connettiamo visivamente dalla, diciamo, dalla control room della Falcor, così ti possiamo salutare meglio. All right, so in a couple of minutes we will probably have, or we'll try to have, a vision of the control room, so that one can have a perception of the organization of our spacecraft of the abyss. Well, so while waiting for another connection from the control room with the external world, we can admire this dancer in the water. They seems to have an attitude to come next to the ROV SuBastian. So normally these are worms and sea cucumbers that are playing for us, very graceful. And now we even have a Latin name for it, Bentodites. Provided by Anna, our biologist. Okay, this is, we can once again make salutation cheer from the control room. So for Europeans, especially Italians.
Hi.
Ciao.
Ciao.
Dando, Marco e Claudio è nell'altra stanza a guardare i suoi sassi. Magari dopo facciamo un'altra connessione. Obviously this was for compatriots back home. Thank you, Karel. Okay, so now we have another interesting, let's say, sample witnessing the human impact. This bottle was on the bottom for sea bottle, yes, because you see it already became the substrate for a polychaete. So it's sitting here since sometimes now. And marine worms were using the surface as the only pebble around, the only hard substrate around. We are recovering the bottle, so we give our contribution to keep the canyon clean. So at least 3 Europeans are following us by now. Paolo and Barbara from Bologna, from our campus, and Siegfried from Belgium.
Yes.
Kind of a pity that you connect only recently, because just half an hour ago we were exploring a cliff that was covered by beautiful glass sponges, cnidarians, barnacles, brittle stars, but we are confident to find something interesting during our trip on the sea bottom. We are in 2,600 meter water depth in the Perth Canyon bottom on the west side. Another sea cucumber. Actually, that we didn't see too many of those before, maybe 2 or 3. And again, you may see this spiral-like cords on the sea bottom, miniaturized Nazca figures that are produced by this acorn worm. That is called, once again, Torquay rator. We may consider by now to raise a couple of push cores for Alexei Sadekov. Is the Russian gentleman on board, is by now associated with the University of Western Australia in Perth. is working on foraminifera. So there is a request by the biologists to collect this weird organism here. And this will be the action of the robotic arm driven by Jason. Push core first for the sediment, and then collection of the thing after on. Thank you, Jason. I like this. Sea bottles is not bad. Yesterday we collected a sea tin and also a sea bag and a sea ammunition. And good afternoon, Australian time, to Davide, presumably from Italy. So now, while we are watching Jason taking one or possibly two push cores for Alexei, we can do different. Again, obviously, we are seeing the result of the fragmentation of the Gondwana supercontinent, but this time was Greater India that moved away Australia, and in the sea in between we start to accumulate sandstone and limestone, and we collect sedimentary rocks, marine sedimentary rocks, of Paleogene to Oligocene age, including beautiful limestone with chert. And the day before this dive, also sandstones, whose age is still unknown to us. The ROV is the SuBastian and has been crafted especially for the to be part of the actually the facility on board research vessel Falcor. And a team of 5 is running the ROV on board Falcor during the expedition. So by now we succeed in securing the first push core from the bottom here. It is about 2,600 meters water depth. The bottom is cold, is 1.9 Celsius. Recently moved to the Institute of Polar Science, so it was bringing 2 CNR Institute on board this expedition that has, let's say, is organized, conceived, and designed by the University of Western Australia in Perth, and the expedition leader is Julie Trotter. She's a geochemist from UWA, and Malcolm McCulloch, same university, a renewed geochemist working on the paleoclimatology and climate change as seen through the ice, actually the skeleton corals. And also the Italian team that I mentioned before. The company is also, let's say, larger by including the Western Australia Museum in Perth and the Macquarie University in Sydney, and by now is the second leg, also the University of Padova, having in the team also Claudio Mazzoli by now. He's a petrologist, as is working in the wet lab by classifying and filing all the rocky samples that we have been collecting during the expedition. We are collecting now this agglutinated thing. This tiny sea pen, this tiny cnidarian here, you can see the polyps are expanded in the water, so it's just feeding, it's having breakfast. Another sea cucumber. For people wondering about these irregular spirals on the sea bottom, those are the action of a peculiar type of worm. Is a acorn worm. It's a big animal. We have seen various specimens at work today. Scientifically, they name it Torquato rator. And perhaps there is one aid. Let's see. No, wrong. And they produce this kind of miniature Nazca figures by completely reworking the sediment during their feeding activity. Another holoturian. Another beautiful holoturia. hard to say how long does a sea cucumber live. First of all, it will depend upon species. I'm not an expert in sea cucumber, and so I'm not in the lifespan of echinoderms at all. I will not be surprised a few years, but not more than 10 years, but that's just a guess. Many marine organisms are just living 1 year or 2, 3 years. This is true for many shells, obviously with some remarkable exception, where we have very longeve sea snails and bivalves. Even barnacles, we have seen that they can survive for 20 years, 30 years. On the average, let's say also the life expectation of a marine organism is not dramatically high. But sorry, I cannot be more precise. Enjoying life on this piece of limestone.
What's that balding on top?
But,
Makes his house out of poop. I can't spell it. Eggs.
So, as we have seen many times, as soon as you get a hard substrate in an otherwise monotonous mobile sediment drape here that is stretching for hundreds and hundreds of meters, then the rock is offering a suitable substrate for the occasional filter feeder. He has the possibility to another ordnance, possibilities another discarded shell, as we have found yesterday. Even found some for the but also there are two interesting things. First, we want to contemplate a little bit the headless chicken monster, especially for those people that are following the live stream. Only after we started to navigate the so this is a remarkable holoturian. We have seen many such specimens so far in Bremer Canyon. And also here. It's really weird. Spero che gli italiani stiano guardando in questo momento, magari fatecelo sapere, mentre vi facciamo vedere proprio per voi che vi siete connessi da poco questo splendido animale, questo loturia. appunto il mostruoso pollo senza testa, come è chiamato. Direi che è abbastanza azzeccato.
Hey, Ray, are you having inappropriate thoughts?
I'm not doing anything. It's Marco.
Marco is a respected scientist. He would never do such a thing.
You know that's a lie. No.
The inspection is over. It's so graceful. Thank you, chap. Okay, now we can go to see this less attractive substrate here. Rather obviously, this place here is great for Aloturians, and I think that is exactly the So actually dive 3 to 8 of ROV SuBastian will be called off in 40 minutes from now. So we will enjoy the exploration of this previously unseen part of the Perth Canyon. Once again, people ashore like us are seeing the bottom here for the first time in life. Nobody has seen or visited by ROV this area before. So what you see, we see. What we discover, you discover. And again, it's always useful to interact with people ashore, providing names, remarks, questions, explanation. So widening a lot of the exploratory team. At the end, we are only 13 on board research vessel Falcor. Of which some 13 belong to the science team, and the remaining people represent the crew and the ROV team. Although if you are so few, again, we represent 5 continents. So we have people from the Americas, from Europe, from Asia, from Africa, and Oceania, of course. And 17 to 18 nations, by also giving the status of nation to those who compose the Great Britain. So captain is from Wales, first officer is from Scotland, and we have a lot of Englishmen. So we have here this block, again of sedimentary rock, potentially serving as an attachment base for epifauna, but apparently in this case not to exploit it. Now let's go to have a closer view. Yeah, not much. Some tiny cnidarians on top. Big animal, now you can see the two. This collection of small mounds made actually by outcropping limestones. In the crevice there was a crab. Again, we can see that there are a lot of large anemones. So here we have another such limestone ridges. The rocks is very friable, perhaps not ideal for important sea life to, in the sense of big colonies of cnidarian to settle on. It is a crumbly, oh, there are barnacles, these are barnacles. Barnacles are light. Now we go to see the barnacles. Okay. Yeah, they are projecting out to the substrate. Yeah, this is always very interesting to see these highly modified crustaceans.
I can. Where would you like me to go? Equipment?
So, do we keep going or we keep going?
Oh, you don't want to grab a couple of those barnacles?
Oh, if you want, yes.
Yeah, why not? 26 is very deep.
So decision is taken to collect a couple of barnacles. These crustaceans, they secrete calcitic multiplate, let's call shell. And we collect a few specimens belonging to at least a couple of species during our investigation of the Australian canyons. And they have also some value for geochemically based climatic studies, as those that are actually the very reason of our expedition here on board Falcor. So the geochemical team, Julie, Malcolm and Paolo especially, they concentrate on calcified skeletal parts as archives of seawater properties through time. And as we have discussed many times, of course, these properties, they are not stable, fixed, but they change according to climatic forcing. So at the end, 3 specimens will be collected, 2 for geochemical purposes, and 1 for the taxonomic assessment of this species. So this will be part of the natural history collection in the Western Australian Museum in Perth, that by now we are very sick to visit after the trip to see what is in there. Important collection not only of the Australian seas but also from all over the world, especially Pacific and Indian Oceans. Just a question, c'è qualche italiano ancora connesso? Okay, see that Paolo is online. Davide, Barbara. And by now Jason's place has been taken by Russell Caffeld, the ROV team supervisor, for the last run of the day. Another can, yeah, marine litter to add to the habitat mapping of the Perth Canyon. Sort of over-silted bedrock cropping out with the sediment here. And actually here the cliff is very steep, but obviously current has to be not that strong because it's heavily silted, so there is no substantial winnowing, and is also the main reason why we don't have important large epifauna attached to the substrate here. Combination of silting, but also probably little approach of nutrients to sustain large filter feeders. So we believe we have we had a blackout with the internet on board. So per, perhaps now we are again online. So we are next to call off our dive for the day. This is dive 329 of ROV SuBastian, research vessel Falkor Schmidt Ocean Institute. We are trying to collect a bamboo coral for combining taxonomic assessment and geochemical needs. In fact, we haven't really met too many of our targets in terms of stony corals. That is not surprising, given that we have traveled the entire day between 3,000 and 250 and 2,500 meter in a temperature regime of 1.7, 1.9 Celsius, and that is not the best for actually finding aragonite corals and not even calcitic. Plus the combination of poor substrate and oversilting of this part of the canyon shoulder is the west side is less impinged by currents, evidently, so there is substantial mud deposition. Still, we were happy to actually to have a glimpse at this part of the Perth Canyon that was previously unknown, completely unknown. No sample, no ROV dives ever, and it will be anyhow very good for the general picture of habitat mapping of the canyons. Obviously, by navigating a very long distance today, we register every piece of evidence that was on our path, as it was in terms of substrate, in terms of biology, presence, occurrence. It was not boring in the sense that we met a lot of worms and a lot of holoturians and other invertebrate form of life. Not too much fish, indeed. Also, we were very pleased by the geological finding. We had these basically limestone And so by now we are closing to call off also dive 329 ROV SuBastian on the bottom of the Perth Canyon. It's been a long day that we started with a very deep CTD dive just to have hydrological information. Basically we explore an uncharted piece of the Perth Canyon from 3000 up to 2500 meters. We observe a lot, we collect not that much. So this is a research vessel, Falkor, Schmidt Ocean Institute. Thanks again to everybody that was ashore connected with us during the day for remarks, opinion, and also for feeding up info about animal life. And hopefully the weather should not be that bad tomorrow, so we may probably contemplate another dive, although we are soon approaching that of this expedition. So thank you everybody, buonasera a tutti, and this is Marco closing the day once again. Bye bye and thanks. Ciao a tutti.